Here's warm-up number 20. How many and what type of solutions does the equation have? So I've got a quadratic equation here, and I could solve the equation for x and just see what kind of solutions I get, but a nice little shortcut is to use what's called the discriminant. And it's the part under the radical in the quadratic formula. So if you remember that, it's going to be b squared minus 4ac. Okay. So if whatever this whole quantity, if it comes out positive, then that means you're going to have two real solutions because you'll have, plus or minus something under the square root, right? So this would give you two real solutions. If it comes out to exactly 0, then you'll have one real solution because you'd be adding and subtracting the square root of 0. So you'd be adding and subtracting 0, which would mean you only have, it's not going to change anything when you add 0, okay? And then if you end up with a negative under the radical, then that means you're going to have imaginary solutions. You'll have the square root of a negative number. So since it's a plus and minus, there will be two imaginary solutions. Okay? All right, so let's try this out then. So with this equation, b squared minus 4ac, I want to make sure this is in standard form. It is here. So, this is my a, my b, and my c. They're just the number parts, right? You include the sign, so c is negative 6. Okay, so let's see. B is 5, A is 4, and C is negative 6. Okay? All right, so let's start simplifying. 5 squared is 25. And I find that often I see mistakes on this part, but just take it piece by piece. Okay, so I'm going to do negative 4 times 4 would be negative 16. Okay, and then make sure you do the multiplication before the subtraction, right? So I'm going to do negative 16 times negative 6. That's going to come out to positive 96. Okay, so I'm going to get 121. Doesn't mean there's 121 solutions, but it means I've got a positive number underneath the square root. That means I'm going to have two real solutions. Okay, so if you find you're making mistakes on the, you're setting it up right, but you're making mistakes after you get the numbers written out, take this part and just forget about the 5 squared, sort that out first, and then do 25 plus or minus whatever you get here. It would be 25 plus 96. That looks like multiplication plus 96. Okay. All right, next problem. We've got a system of equations. This one's actually going to be a circle, which we haven't graphed before, but it doesn't matter. We can still do this algebraically, and this is going to be a line. So if you think about a circle and a line, they might intersect 0 times. It might miss completely. It could intersect once if the line just is tangent to the circle and just touches it in one place, or it could have two solutions. Okay, so I'm going to solve this by substitution. So for substitution, I want to isolate one of the variables in one of the equations, and here the y is catching my eye because the y is already isolated in the second equation. So I might as well use that to my advantage. So y is equivalent to 7 minus x, okay? And that means in this top equation, I can substitute in the quantity 7 minus x in place of the y. So let's do that. I'm taking that top equation. Use parentheses when you do this. Okay, and then we're not just squaring both terms. Don't just square both terms because this is a binomial times itself, which means we're going to have to FOIL. Okay. Okay, so foiling here. I'll just put the foliage like that. All right, so first, 7 times 7 would be 49. This is the F part of FOIL, okay? Outer, 7 times negative x is negative 7x. Inner, negative x times 7, negative 7x again. And last, negative x times negative x would be positive x squared, okay? So I got it down to this. Let's start cleaning it up now. So I'm going to start combining like terms. I can combine these two, and I can combine the x squareds, right? So x squared plus x squared would be 2x squared. Negative 7x and negative 7x is negative 14x. And then I've still got the 49 over here. Okay. Now, I still have like terms, so let's combine these. So let's say I wanted to subtract 49, it'll also set it equal to 0. And something kind of nice happens, those both cancel each other out, so now I'm down to 2x squared minus 14x equals 0. Okay? All right, so let's try to factor this so that I can use the zero product property. So I don't need to set up a diamond problem or anything like that because I've got a common factor here. 2 goes into both of these, but so does x. So let's factor out 2x. So 2x times something is 2x squared. That would be x. 2x times something is negative 14x. That's negative 7. Okay, and now we're ready for zero product property. So one of these two things has to equal 0. Okay, if 2x equals 0, when I divide both sides by 2, then x equals 0. Okay, and then over here, x would equal 7 when I add 7 to both sides. Okay, now I want to be careful because these are two x values. That means I'm kind of thinking there's going to be two intersections. Maybe this is, you know, if I graph this, it'll look something like that, and I've got two intersections. So I've got two different x coordinates at both those places, but I'm also going to have two different y coordinates. So don't forget to find the y coordinates that go with both of these x's. So let's start over here. I'm looking, okay, if x is 0, I want to go back to one of the original equations. You can choose which one. I'm definitely going with the second one just because it's simpler. And I'm going to plug in 0 for x. And then so y equals 7. So when x is 0, y is 7. So that's one of the intersections. And now I'll find the other intersection in the same way. So going back again to that second equation, this time I'm plugging in 7. And 7 minus 7 is 0. So when x is 7, y is 0, and there's the other intersection. Okay? And there's our solution. That's the end of the warm-up for today, and I'll see you next time.